Hi, I'm Morning Coordination Meteorologist John DeBlock from the National Weather Service in Birmingham, Alabama. One of the most frequently requested items that is asked to be seen when touring the National Weather Service is to see the weather balloon launch. We thought we would take this opportunity to put together a video that shows you the highlights of the process from beginning to end. Let's join meteorologist Gerald Satterwhite as he prepares for this late November evening weather balloon launch.
All right, so we have started the software that is going to track our weather balloon, and the next step is to get some of the instrumentation. All right, so we have our Radiosonde here, our weather balloon, which will look a lot larger than this pretty soon, and a parachute for when all this comes back down to the ground.
From beginning to end, the entire process of assembling the balloon and preparing it for launch takes on the average about 20 to 25 minutes.
All right, so this is the Radiosonde we currently launch every morning and evening here at the National Weather Service. We'll actually be going over to a different type of Radiosonde when we switch over to a new system in early December, but this is the one we're launching today. It's not too heavy, but we have a few different instruments on here. This one measures the temperature. This measures the humidity in the atmosphere. And on the inside, there's an instrument that measures pressure and a GPS device that measures, helps us measure the wind speed and wind direction depending on how fast this is moving in any direction. So this will give us a snapshot of different weather variables from the ground to way up in the atmosphere, which is then fed into forecast models to help us predict what's going to happen 5 days from now or 5 hours from now.
Gerald will now prepare the instrument and our tracking and monitoring system for launch by entering in the current temperature, humidity, wind, and pressure data, as well as other information about the balloon and instrument. This process ensures that we accurately collect the weather information that goes into a successful weather balloon launch.
And so right now we're doing a process called baselining. We're basically making sure the Radiosonde has a pretty good connection with the software data and the outside antenna. And we see some of the data starting to come in here. Just making sure, just let it sit for a little bit to make sure we have a steady and stable connection. And one of the cool things about this, eventually this Radiosonde will come back down to the earth. It could be in your backyard or out in the middle of the woods, but there's a small mailing bag attached. So if you ever find one, you can mail it for free. Just drop it off at your local post office, and they will return it to a reconditioning center. And there's a little area on the side here. We're going to write down Clare, Alabama. That's where our office is, and the time and date that we launched it. So just some tidbit information there if you ever happen to find one of these. As you see on the side, harmless weather instrument. So don't panic if you do see one of these land in your neighborhood. It is possible the balloon may have a little bit of the hydrogen gas left over in it, so you do want to keep your distance, especially if it lands near any utility lines or anything like that. But overall, the parachute and this instrument are harmless.
Just a few more steps to tie up a few loose ends with this instrument, and we'll be ready to take it outside and on to the next step.
All right, so our Radiosonde is well connected to the software and antenna outside. So now we're going to head out and inflate the balloon.
Oh yeah, there's other things to consider when launching a weather balloon, like nearby power lines and the fact that we're located at a fairly active airport. We sure don't want to interfere with any aircraft operations when we release that balloon.
So this is our upper air building. This is where we're going to inflate the balloon, attach the parachute, and then attach our Radiosonde and launch it. But before we get to launching the Radiosonde, we've got to fill our balloon here. And it's not a party-sized balloon. It is fairly large here. It gets around 6 feet or so in diameter once fully inflated, and will expand many times that size once it reaches the upper levels of the atmosphere. Well, we just need to attach the balloon to our nozzle here, and put our grass burr on there, make sure it doesn't slip off. Our hydrogen tanks, we'll just open the valves here. It looks like we're getting a little bit low on this, so we may have just enough to inflate this balloon. We may have to swap it out.
In the 7 to 10 minutes that it takes to inflate the balloon, we prepare the parachute and string needed to complete the assembly of the balloon train. That's the balloon, parachute, and weather instrument.
Alright, so our balloon has now lifted the post. We use predetermined amounts of lift depending on the weather conditions. Today we have fair weather, there's no high wind or precipitation, so we're using the minimum amount necessary. If we have precipitation like rain or sleet, freezing rain, snow, anything like that, or high winds, that could affect the lift of the balloon or its ability to rise through the atmosphere, we would use additional lift. But we're good to go right now. The post is lifted, so now I'm going to turn off the hydrogen so there's no more coming through the tube, and then we will tie it off and connect it to the parachute and our radiosonde.
We're almost done. The balloon is gassed up and Gerald is wrapping up with the final steps of sealing off the balloon and attaching it to the top end of the balloon train. We're almost ready to walk it out for the launch, but here comes another airplane.
Alright, so we're completely tied off here. We have our inflated hydrogen balloon with our trailing parachute just to slow it down on the way back down to the ground. And then we have a long piece of string going all the way out to the actual weather instrument itself, again called the radiosonde. And we like to have a pretty good amount of distance between the weather instrument and the balloon, just so that the instrument isn't hitting the balloon, and also the balloon can be giving off heat as it's going up. And so we want to measure the atmospheric variables, not anything coming off the balloon. So that's why we like to have a pretty good separation between the two. Okay, our balloon is now in the air. It's currently headed toward the southwest, and we'll probably turn a different direction as it gets higher in the atmosphere. We're going to go ahead and get a lock on the GPS signal on the radiosonde. So you will see the antenna is now swinging around to the direction and altitude that balloon is traveling at. We just want to verify our surface conditions. So we're entering the current temperature and dew point here at the ground with a surface weather station outside our office, and then the balloon is continuing that data collection vertically through the atmosphere. So kind of a cool conditions out there right now, 53 degrees, dry with a 29-degree dew point, and the wind is calm, clear sky. And we just do some quick data checks here to make sure nothing funky is going on with the pressure, temperature, or moisture readings. It looks like everything is good to go. And here is what the data looks like as it's coming in. So it comes in basically by the second, and we'll be able to track the air temperature in red, the moisture content in the blue line, and then these barbs you see off toward the right indicate the wind speed and wind direction. And this will give us a pretty good snapshot of the atmosphere, again from the ground to many of thousands of feet up in the atmosphere. This balloon will actually travel probably around 105,000 to 110,000 feet in the atmosphere before it pops. But we get a lot of really important data, especially in the low levels. This is strictly temperature, moisture, wind speed, and wind direction, but we can derive a lot of different variables from that, including instability, wind shear, that sort of thing that can help us forecasting severe weather. If we were in a winter weather scenario, the temperature data in the lowest few thousand feet of the ground is really important in determining whether or not we're going to have snow, sleet, freezing rain. So a lot of information we can use in real time, but also this same data is going into the forecast models as well. And it's not just our office here at the Clara station. We have balloons being launched roughly at the same time every morning and evening, not only across the U.S. at different National Weather Service offices, but across the globe as well. So international balloon launches go in, and all that data is fed into computer models. Oh, we have a lunch rate this year.
After about 25 minutes of flight, the first bit of data is ready to be transmitted and shared with meteorologists everywhere. The software creates a message for the meteorologist to review and transmit. Now, the data is collected automatically, but it's always monitored and checked for any abnormalities that might occur. If any abnormalities do occur, they are found and edited according to very specific rules. After somewhere around an hour and 10 minutes of flight, the balloon has passed through the troposphere, which is the part of the atmosphere that produces the weather that is responsible for what we experience here on the ground on a day-to-day basis. Another weather message is created for the meteorologist to review and transmit for other meteorologists to view and for the weather forecast models to run.
All right, almost there. Okay, so our balloon has now terminated, and it popped around 106,000 feet. Now, a lot of the data way up in the atmosphere. It's not a huge use to us. But here's what the plot looks like. Let's pull it back up here. Again, the red line is showing the temperature, and the blue line is showing the humidity. So the farther apart those lines are, the drier the air is, and we have a very dry air mass in place right now, so those lines are pretty far apart. And very calm winds down here at the ground, but blowing looks like around 50 to 65 knots up there around 30, 40, and 50,000 feet. So now that the balloon has popped and we've collected all the data we need, we will transmit this data to our national centers and in CEI for archiving of the data. And our next balloon launch will be tomorrow morning.